Hello students, you might be doing great, and in this clip right now in chapter number 4 we will learn that magnetic field at the center of a circular coil carrying current. Let's say we have a such type of a circular coil, and I am just allowing current to pass from it, and the same amount of current is coming outside as per you can say Ampere circular law. Let's say you have this much radius, and this is the very small segment of length dl, which is perpendicular to this r. So your direction of magnetic field will be like that. You can also apply your thumb rule. So this is the amount of current. Now we want to find it out its expression. So you are aware about this expression. dB is equals to mu 0 upon 4 pi. You have IDL cross vector r divided by r cube, and we want to remove this vector symbol, so I'm just putting that dB is equals to mu 0 upon 4 pi IDL sine theta divided by r square. You are aware about this formula, which is when we have learnt under the roof of Biot-Savart. Now you are aware that I have told you the direction of magnetic field, direction of dl and r both are perpendicular. So I'm mentioning that theta is equals to pi by 2. So my values I'm placing this expression will give me dB is equals to mu 0 divided by 4 pi and IDL divided by r square. You can see that this is the circular coil. Let's say this is my coil. I am just cutting from it and just making a straight wire. So this is the length of it, and this is called as the circumference of it. So what I am doing is that first of all taking integration dB mu 0 upon 4 pi I divided by r square integration dl. So you are aware that integration dl is called as L, and the value of L, which is called as 2 pi r. So I can have integration dB is B, and that would be mu 0 I, then 4 pi r square, and dl is called as a 2 pi r. I am just cancelling this r, so I can have a B is equals to mu 0 I divided by 4 pi r multiplied by 2 pi. And this is very much important expression, because let's say if we have n number of rings, so this my expression will become n times. So mu 0 I divided by 4 pi r into 2 pi multiplied by n times. So this is the expression. Now we will come to the another part, which is called as a Mentos khao, dimag ki batti jalao. So in this segment we will just say that B is equals to mu 0 I divided by 4 pi r multiplied by 2 pi. What is that? Theta. This theta is called as a 2 pi. So for my reminder part, what I will just make is that make it is mu 0 I 4 pi and r multiply by angle. Yes, this is very much important expression, because I am using this word mu 0 I upon 4 pi r into the angle, because there are some of the examples which we are just after this clip we are solving are very much important, because it has been asked in so many exams like JEE and AIMS as well. So always remember, it is called as a mu 0 I upon 4 pi r into angle. If there are number of turns, so we will just multiply angle with n. Likewise we have this expression that is called as a mu 0 I and 4 pi r. So keep in mind, whenever you have any type of angle or any geometry which contains some angle, in a previous task we have learned that formula of parallel wires. At that time we have used sine phi 1 and sine phi 2, or cos phi 1 and cos phi 2. But if you have no parallel wire and such type of a close or loop type of geometry or circular geometry or any different type of a shape which contains some angle, so we will just only focus on this expression. It is very good example, mu 0 I upon 4 pi r into angle. So after learning this theorem, we will just go to the another very important examples which have been asked in the past and maybe asked in future. So students, keep this formula in mind. Thank you.